just a couple of videos that go over the stuff that Mr. Barker went over while I was away at the end of the year. Okay, so the first one, all these things you learned from me in year 11, they're just a bit further on in this section, chapter 5 of the book. So I put revision from year 11 because they are, and I put some work that you should try to do before you come back up there. Okay, so the chain rule, we know, says that when we take the derivative of a function inside a function, we have to take the derivative of the outside part and then the derivative of the inside part. So I'm just going to put a little thing up here to remind you. So we might have done this last year where we had something like 2x squared minus 4x inside there and a 3 there. So we have a function inside the function x cubed. So this thing is the x at this point, and so I want to take the derivative first of x cubed. So I go, okay, y dash is 3 times that stuff that's in there, whatever's in there, and then I take 1 off, because that's the rule for the derivative. And then I take the derivative of the stuff that's inside, and I multiply by it out here. So times by, or I can put a bracket, and then the derivative of that, so 4x minus 4. And that's the derivative. Okay, so let's go down to the first example. They give you 2 different rules here, and I think those are the rules that are on your formula sheet. So here we go, examples from your book. So the first one says use the chain rule to determine the derivative. So I'm going to use the good formulation of dy dx. I'm not going to use y dash. And I'm going to take the derivative of something to the 7th. So I get 7 times the something, that stuff that's in there. And I take 1 off the 7 and get 6. And then I multiply by the derivative of that. Now, if you don't put brackets here, it's not going to work out for you. That's a huge mistake that people make on the exam. Remember, it's just that stuff. The 6 has already been taken care of before. Use brackets. Okay, let's try this next one. It's got a fraction in it, so maybe a little bit harder. So I'm going to go dy dx equals 2/3 bracket 4x minus 7, and then I have to take 1 from 2/3. Now, if you need to do that on a calculator, you can. I hope you can do it in your head, or you can do it off to the side where you go, okay, I need to take 2/3 from, or take 1 from 2/3. Well, that's 1. So it's negative 1/3 that goes up there. Oops, sorry, negative 1/3. And then the derivative of what's inside is just 4. So in this case, I could multiply these two numbers together. Usually we do that to simplify. When you multiply a whole number by a fraction, you're multiplying by the numerator. So it's 8, 2 times 4, over 3. And I could even put this down here, and 1/3 kind of looks like this. Okay, so 1/3, negative 1/3 means it goes underneath, and it's a cube root. The 1/3 is a cube root. So just quickly, those rules, you know, x to the 1 over n is the nth root of x. This isn't a derivative, it's just a index law. And x to the negative 1 over n would be 1 over the nth root of x. Okay, just remembering some of those laws and how they work together. Okay, last one. Determine the derivative of that. Okay, so this is a lot of stuff here. Okay, I've got the cosine squared of this thing. So this thing is not multiplying by that. It is the argument of the cosine. And so really what I have, I'm going to put part A right here. Really what I have is I have that y is equal to, and I'm going to go like this, big set of brackets, cos e to the 2x, so that's the argument of the cos, squared. Okay, so that little 2 is really that 2. We just use this abbreviation so that we don't think that we're squaring that argument, that we're squaring the actual whole thing, and that's why we put the 2 there. You'll get used to that, or just rewrite it like that. Okay, so here I go. I have that thing squared. So the first thing I need to do is take care, I'm going to put y dash, I'm going to put the 2 out here, and I'm going to cos e to the 2x. And 2 minus 1 is 1, so that's fine. Now I need to take the derivative of that, And the derivative of cos is negative sine. So I get times negative sine of e to the 2x. And then I need to take the derivative of that. And the derivative of that is e to the 2x times 2. So it's like a lot of chain ruling there. Okay, it was the first rule, then the second rule, and so I went inside 3 times, 3 things in the nest. So I'm just going to set this out a bit nicer. So I'll go negative 4 e to the 2x, and then I have times cos e to the 2x sine e to the 2x. And if you like brackets in there, that's fine, if you want to put the arguments in brackets. Okay, then part B says evaluate when x is 0, giving your answer correct to 4 decimal places. Okay, so I'm going to put the B, try to scooch over a little bit. I'll put the B right here, I think. So at x equals 0, I have negative 4 times e to the 0, 2 times 0, cos of e to the 0, sine of, I'll put it in brackets, e to the 0. Well, e to the 0 is just 1. So I get negative 4 cos of 1 sine of 1. Okay, now that 1 is kind of confusing. I mean, is it 1 degree? No. No, all these problems here are going to be in radians. Yeah, they're all going to be in radians. So if there's no degree symbol, and there certainly is no degrees up there, then you know it's radians. And so I just grab my calculator because it says to 4 decimal places. I don't have my cord to charge my good calculator, so we'll have to look at this one. So I'll go negative 4 times cos 1 times sine 1. And I'm in radians there, you can see, okay? And I get that. So that's equal to negative 1.8186. And that's to 4 decimal places. Okay, there's plenty of problems there to do.